How you doing, guys? Welcome to Plumbing's Cool. This is how you gas weld steel pipe using an oxyacetylene torch. Wait a minute. Did I just say weld? Yes, I did. So the first question is, do plumbers actually weld? The short answer is yes and no. First, let's clear up a massive misconception. Welding is not soldering. For all intents and purposes, plumbers solder, and there's a big difference between the two. I can understand the confusion, but let's clear things up. The act of soldering entails the use of a filler material, aptly called solder, to fill in the microscopic gap that sits between the fitting and the pipe. Welding, on the other hand, uses extremely intense heat to actually heat the materials themselves to a molten state, which allows the materials to actually fuse together to become one. Okay, back to whether plumbers actually weld on the job or not. For all intents and purposes, no. The wonderful art of welding is a bona fide trade in and of itself. The truth is that if a plumber's on a job requiring any serious welding work, such as for gas lines, they're going to hire a real-life welder with a valid certification, who's likely more well-versed in the skill than they are, or at least they should be. Interestingly enough, though, here in Ontario and other provinces in Canada actually mandate welding as part of our formal college training. And having some welding skills certainly has its perks. Small patch-up and repair work, cutting up and modifying steel structures, and various arts and crafts. There are, however, steel fittings that are actually designed to be welded. These are referred to as socket weld fittings. So in the spirit of plumbing, let's take a look at gas fusion welding steel pipe. Let's look at what we're going to need. Filled oxygen and acetylene gas cylinders. Regulators, hoses, and a torch with a number 3 or 4 welding tip, and flashback arresters for safety. Leather or hide welding gloves. A sparker for firing up your torch. Oxyacetylene welding goggles or a face mask with a number 5 shade. A steel wire brush for cleaning up all your welded joints. Schedule 40 steel pipe devoid of any oil or fuel deposits, which could cause it to go boom during the process. Socket weld fittings of the same nominal pipe size as the pipe. 332 or 1/8 R45 or RG45 filler rod for filling in your welding joint. A pipe vise or some other equipment that can securely hold your pipe as you weld. You're also going to need some form of protection. So traditionally welders use a rawhide sort of covering, which is nice and available, but if you don't have one, at least cover yourself with some sort of flame retardant or flame proof piece of clothing. In this case, I've got a vest, which fits me quite nicely and makes me look rather pro, if I do say so myself. So I just think I just went up 10 IQ points.
Yeah, sure. Mm-hmm.
Okay, let's get started. But first, a few words on safety. There are some significant precautions when welding with oxyacetylene. The gases could be very dangerous when mishandled, and you'll be working with an extremely bright and hot flame, which could be damaging to your naked eyes. So take the following safety precautions whenever gas welding. The bright flame emits radiation, which can be damaging to your eyes. Minimize looking directly at the flame for a long period of time without adequate eye protection. To protect your eyes, use number 5 welding goggles, or even better, a face shield with a number 5 shade. And welding produces toxic fumes, which you certainly want to minimize breathing in. So make sure you have adequate fresh air ventilation when welding. Make sure that there are no flammable materials or fumes anywhere within the vicinity you're welding, which could prove detrimental. And finally, be sure to have a working fire extinguisher and a bucket of water within arm's reach to prevent things from getting a little too hot for comfort. A bit about acetylene gas. Acetylene is a very unstable fuel and can theoretically become self-combustible at working pressures greater than 15 psi, or pounds per square inch. Therefore, never set your working pressure to greater than 15 psi, hence the red line markings on the regulator's gauge. Theoretically, even an abrupt shock, such as a hit with a hammer, may cause acetylene to spontaneously explode. In order to stabilize this capricious gas, the cylinders consist of specially designed porous materials within them and contain acetone, which enable the acetylene to become non-reactive while contained. This is another reason why you should never, ever run your acetylene at a high rate and at a low cylinder volume, because doing so may cause the protective acetone to get sucked out with it. With respect to storage of acetylene cylinders, always store and use your cylinders in an upright position. If your cylinder has fallen to its side or has been stored as such, reposition it to the correct vertical position as soon as possible, and do not use it until the fuel has been given enough time to settle. The general rule is to allow the cylinder to sit for as many minutes that the cylinder was on its side, to a maximum allowance of 24 hours. Start by checking your hoses and regulator connections to make sure that nothing is loose, cracked, or broken. The red side is always acetylene, and the green side is always oxygen. Now if you look, you can see we've got O for oxygen, F for fuel, and the reverse threads. The oxygen side has right-hand threads, which threads in a clockwise direction, and the fuel side has left-hand threads, which tighten in a counterclockwise direction. That's so that you don't confuse the two. Ensure that flashback arresters are installed immediately upstream of the torch handle. These are safety devices that prevent any unintended combustion from occurring upstream of the hoses. And clean your welding tip using the proper tip cleaner to remove any dirt which may cause a bad flame. Setting up and lighting your torches. With both acetylene and oxygen tanks closed, with the cylinder handles turned all the way clockwise, turn both regulator controls counterclockwise until loose to fully reduce the pressure on the downstream side of the regulators, which will allow you to set the pressure upward toward the preferred working pressure, or in case the previous user didn't set the pressures correctly. So we'll start by opening up the acetylene. When you open up the acetylene, open it up counterclockwise, only a quarter turn. There are two gauges here. The gauge on the left side usually indicates how much is in the tank in terms of pressure. So it's not atypical for a tank of acetylene to be at about 200, 250 psi. The right side gauge is the amount of fuel downstream or after the regulator. So what we're looking for, one important factor with respect to operating acetylene, is that you should never, ever, ever operate above 15 psi. Hence the red line that we see over here. So what we're going to first do, we open it up a quarter turn. The reason why you want to open up only a quarter turn is because you want to be, even a half turn's okay, but you want to be able to turn it off quickly in the event of an emergency. So leave this key on here. Now, once we do that, we want to regulate our pressure. So before we regulate our pressure, we're going to open up our acetylene side, about a half a turn or so. And then we're going to start backing off the regulator clockwise. We're going to hear acetylene gas coming through the hoses. Remember, you do not want to pass 15 psi. The reason why you want this open, because you want a working pressure of about 5 psi. That's where that number 5 is. So we're going to keep turning clockwise until we get about 5, 6. You might get some fluctuations in pressure. Ultimately, you're looking for working pressure of about 5. Now, when you shut off, your pressure is going to shoot up a little bit on your gauge, which is normal, okay, because we're looking for working pressure. As long as it's above 5, we're good. Now we're going to open up the oxygen side. Oxygen side, open it up counterclockwise. Okay, remember, our regulators are backed off. Fully open on the oxygen. Same thing now. This time we open up the oxygen side. We're going to regulate the pressure for the oxygen so that it's approximately, this is our full gauge, remember that? We're showing a little less than 1,000 pounds, which is quite a bit, and that's what makes oxygen actually quite dangerous. Not so much because oxygen itself is flammable. It's not. It could make other gases flammable, but there's extremely high pressure in here. And it could be dangerous if this is mishandled, because there's a significant amount of pressure that can lead to some serious issues if this thing ends up getting hit inappropriately or if it drops off a high spot. So this is fully open. Going to open up our oxygen side so it's free flowing. And we're going to start to back off the regulator, actually activate the regulator, until we see about 10 psi. Each line on the inside number is about 5 psi. So I open up my oxygen. I can hear it flowing. And I'm going to increase the oxygen flow till I get about 10 psi, which seems pretty good right there. And now we're going to shut this. While we have this off, we're going to check for leaks by keeping our valves off. Remember, now these regulators are open and this is under pressure. So we should have a working pressure here that won't fall. And we should have also, there should be no leaks whatsoever. Now that our pressures are set to approximately 10 and 5 psi respectively for the oxygen and the acetylene, we can begin to adjust our torch. All right, this might get a little bit bright. First thing we're going to do is open up the oxygen. There's a very famous saying that welders use: A before O, or up you go. I have no idea where that came from, but the general rule always has been, when you turn on the torch to adjust it, you first open up the fuel, which makes sense because without fuel you can't light anything. The oxygen will not light on its own. Now, consensus for the longest time has been, and this is how I was taught, to turn off the fuel as well. Now lately, as of late, there's a lot of contention about that. I think the more recent school of thought is that you turn off your oxygen first. Turn on only the acetylene, and what you're going to do is just crack it open a little bit. You're going to have your sparker, and we're going to look for a flame. Okay, keep it away from you, point it away from any flammable objects. Make sure that you have ventilation around you. Here we go. Now that we have this flame, if you adjust the acetylene, you're going to see some smoke. You want to get it and open up the acetylene until the smoke just about disappears. That's what we're looking for, right there. Now we're going to open up the oxygen side. You want to get it so that you have a very fine cone right at the bottom. That's called a neutral flame. And it sounds a little strong to me. That's our neutral flame. Turn it off, oxygen first, then the acetylene. You see a little flame there. That flame should disappear. We have flashback arresters, and that's supposed to protect from the flame backing up into our hoses. If you get a flame that's continuing, that means that our valves are leaking. So you want to tighten it to the point where it no longer leaks. If it continues to create a flame, then that means that you need to repair these or have them replaced because they're not stopping the gas from flowing. Very important that the gas ceases to flow. This is why it's also important to have proper shutdown. Okay, so that neutral flame is often a little tricky to see on camera due to the torch's intensely bright light. So let's try it again with a slightly lower exposure, but not without some super cool dramatic slow motion ignition first. That never gets old. Remember, once you remove much of the black smoke from your acetylene feed, you need to carefully adjust your oxygen level until you get that. So with our pipe reamed, and I just quickly welded a small component here just to hold on to this T so that we can keep this pipe horizontal. We ream one end of our pipe. No need to clean it any further, as long as it fits in nicely. Nice and tight in there. And you don't have to worry too much about keeping it straight yet. We're just going to tack it right now at this point. Then maybe we'll try and straighten it up a little bit with the hammer. Normally, we'd put a square here to make sure that it's all nice and square before we actually go all the way around and button it all up. But for this demonstration, we're just going to demonstrate the seam going around. So here we go, glasses on, torch at the ready. A first, flowing at about 5 psi. That's a little strong, so we're going to reduce it. So we see a little bit of soot, black smoke. Eliminate the black smoke by opening it up. Then we open up our oxygen till we get ourselves a neutral flame. Not too quickly. There's our neutral flame, nice and tight. Looks pretty good, I think. And I think we're good. Let's make our first tack. So we're going to direct it at the seam. And as we direct it at a 45-degree angle, we'll start to heat up the pipe. And we're just going to dip our rod in there. Now initially, if we're just tacking, we might not even need to dip it. All right, oxygen off first, followed by acetylene. See what that looks like. I'm just gonna try and square this up by eye. We have our first initial tack here. Looks pretty good, I think. And let's just try and straighten it up a bit now. Normally I put a square here. We're just gonna do this by eye. That's pretty good. Okay, so we're going to start up our torch again, and we're going to go all the way around. So our goal here is to get that cone, which is the neutral, when you have a neutral flame, to get that cone, that inner cone, to just about touching the steel. That's the hottest part of the flame. So as it directs, as we direct heat at a 45-degree angle, the hottest part of the flame ends up heating up the metal, and the cooler outer part of the flame starts to preheat the metal as we go along. And as we go along and start to heat it up and get it hot enough, we dip our filler rod. And hopefully we're going to make a nice weld all the way around. Let's see how this goes for a plumber. That's not bad. Now let's get going. I'm going to go this way. Hopefully you can see it. Preheat. Wait till it gets flaming hot. And we're going to start to dip. Directed at a 45-degree angle. Now I'm going to go this way, just so you can see it. Okay, I'm going to spare you the remaining agony of this torch's ear-bleeding hiss and speed this up a bit for you. As a recap, what I'm trying to do here is direct my torch at a 45-degree angle at the weld seam and toward the direction I'm welding, with the flame's inner cone touching the joint or as close as possible. As the materials begin to pool, I dip my filler rod at the joint's intersection to build up a seam and continue to do so as I work my way around the joint until I've gone all the way around. Not bad for a plumber. Once you're satisfied with your work, let it cool naturally for a few minutes and then clean up all the soot using a steel wire brush. This will also help you better see any other welding issues or imperfections. If you find any, fire up your torch once more and patch up any issues. And now that we finally completed our weld, ultimate step is to make sure that we can put away our cylinders safely by purging all the lines and isolating the cylinders from the hoses. So what we're going to do first thing is turn off the acetylene. And again, because we only open it up a quarter to half a turn, should be easy to close. Nice and firm, close clockwise. We're going to fully close our oxygen. Fully closed. Now, before we do anything else and touch our regulators, we're going to open up our needle valve on our torch. Starting with the acetylene, you're going to hear air escaping, or rather acetylene escaping. That should allow the pressure in the regulators to go fully all the way down. That means you're going to be purging the regulator both on the upstream side and the downstream side, because you want no flammable gases to remain inside the hoses. So now this is fully open. Now we can back off the acetylene regulator, turning counterclockwise. That's going to decrease pressure. And again, your gauges should show 0 on both sides. We're doing the same thing with the oxygen. So we're opening this before we touch the regulators, with both cylinders shut at their main valve. Now we do the same thing, back off counterclockwise with the oxygen regulator. And again, we should see no readings whatsoever on both the left-hand side and right-hand side gauge. That tells us that the regulator is empty at both upstream and downstream. And now this can be safely tucked away and ready for use next time. And so that's how you weld steel pipe using an oxyacetylene torch. Really hope this video brought you some insight into oxyacetylene welding. If it did, then please be sure to fire up that like button and subscribe to this channel. Feel free to drop me a comment below if there's anything else you'd like to see that might be tickling your curiosity with respect to all things plumbing. Thanks for watching, guys. All the best. I can't see. How?